Yep. Okay. So before we continue, does everyone have the Edison robot for the last time? Does everyone have the Edison robot and the cable? Yep. Awesome. I can see Alex, you've got yours. Awesome. Okay. I can see Shani, you've got yours. I see Jen's. I can see Aaron. Lewis, is yours in? Nice, awesome, good job, Lewis. Okay, so we have a lot to cover today. So this will be our last lesson. Um, so what we're gonna do is, first of all, we're gonna make sure we will make sure we just cover what we've done last lesson that we didn't have a chance to complete, and then we will go on to the final content of the class before we end up finishing for the term. So does anyone have anything to demonstrate from last week? Or is anyone feeling brave enough to demonstrate anything? Nope. Okay, so what I want everyone to do is just to copy and paste this code and try, first of all, everyone just try copying and pasting this code. I'll just paste in the chat. And then what I want everyone to do is just to basically set it up in a way that you'll make the Edison robot drive backwards, but drive in, so drive backwards and spin left. Um, so um, yeah, so that's what I want everyone to do, is to make it drive backwards and spin left by changing this number. I'll just quickly set up on mine as well. Um, okay, so if you see my program running, it pretty much drives forward and spins to the right. But I want to make it drive backward and spin to the left. I'll give you all 5 more minutes. And what you also recognize this code will do, I want you all to make it drive forward after driving backwards and spinning right. I want you to make it drive forward as well, based on what was done in the code. Yep, Alex, what's up?
My
Yep,
cable,
Alex.
my cable's not working.
Are your cables not working? Did you try changing your batteries? It might be your Edison robot itself.
No, but when I plug in the cable without the Edison robot, I can still hear all the sounds.
Maybe just, I think that should be fine. Maybe just try it again and try programming on your end.
Okay.
Can you fully plug it in?
Yeah, make sure you fully plug it in as well. Okay, you have 3 minutes. Only 1 more minute left. So, yeah. If anyone figured it out, who wants to demonstrate? So pretty much, yeah. So make it drive backwards and turn left. Okay. Does anyone want to demonstrate? So with your current code, you drive forward, and spin to the right. But let's try to make your code go backwards and spin left. You have to check these conditions. You have to find the conditions that will make it do both tasks. And a bonus challenge is to make your Edison robot move forward as well. Okay, does anyone want to demonstrate? I'll give you a hint. If you're struggling, I'll give you the hint. Basically, you can't set I'll give you the first hint. You can't set the x equals to 10, because if x is equals to 10, you drive forward. But now you have to make x a value that will make it spin left. I'll give you 2 minutes. So the x can't be 10, but x has to be equal to something to make it spin left. Okay, I've got an answer. Gregory, do you want to demonstrate with an answer, or does anyone else wants to try out x equals to 3? Okay, awesome. I can see Jen, you got yours working, and you got it driving forward as well. But as long as the first step is to make it drive backwards and spin left after you press play. Okay, so who else wants to try x equals to 3? Okay. Okay, so okay, if Gregory, do you want to unmute? Gregory, you there?
Yeah.
Okay, so what is your Edison robot end up doing?
I haven't copy pasted the code yet, but in the chat I know what it means because it says x equals 3 to spin left, and
Yeah.
if it's else than 10, then it will drive backwards. So
Yep.
they both fit into that.
Okay, that's they're on the right track. Okay, awesome. So you have to set x is equals to 3. So Gregory is on the right track. So this is what will end up happening. So if you look at my camera, this will end up doing this. And then if I make a sound, a big sound, you drive forward. So yeah, so pretty much x, how it will work is x will check, is x equals to 10? No, it's not equals to 10. Otherwise, you drive backwards. Okay, so now moving on, is x not equals to 3? No, it is equals to 3. So it will spin left. Okay, you wait a few more seconds, and then this is where we did another thing called using the sensors given by our Edison robot. We check if you pretty much like keep running this loop until you can hear a sensor. You'll make a beep, you drive, and you'll make a beep. So let's just do this one more time. So it spins around, and then nothing happens, and then because I made a big sound. So let's try this again, but I'll make it more obvious. Yep, okay, awesome. So you made a sound after a few seconds, and then you'll make a beep, drive forward, then make a beep. Okay, hopefully it makes sense to everyone. We should move on. But does anyone have any questions before we move on? Nope. Okay, so what we're gonna do now is we're gonna do another. Okay, Aisha, what's up?
When I do the program,
Say again?
when I put the program Edison, and then I wait for.
Can you say again? Your internet connection is breaking up.
Do you hear me?
Say again? Sorry, your internet is breaking up. Can you say it one more time?
When when I do program Edison, not flash.
I'm not sure what's happening on my end or your end, but I can't hear you properly. So if you want, you can just type your questions in the chat. Okay. Moving on. So what we're going to do is event handlers. So what we're going to do is whenever your Edison runs something, whenever your Edison robot runs something, then whenever it detects an external event, then it will stop the program and then do something else before returning to the program. So let's give an example. If the Edison robot like detects an obstacle, you execute a move that when you detect an obstacle, and then you will keep running your function. So what we're gonna do is just stay with me. I'm just gonna quickly look at my notes. Okay, so what we're gonna do is we're gonna open the what's it called, the beam detector. But before we do that, let's just see what is her question. When I press program, the Edison LED light don't flash. Okay, so the issue with that is you probably need to turn it on. When I press program Edison, oh wait, doesn't flash. Okay, just maybe turn it on and turn off your Edison robot and try again. If it doesn't work, then change your batteries. But mind you, you have to make sure your Edison robot is turned on, your cable is connected, and put into your computer. You press this circle button. You should see like a two light that is flashing. No, the two light that is on. You can press program Edison on the top right corner, and then yeah, precisely. Mainly because I am looking at my other notes as well, just to remind myself what the code is. That's just fine. Okay, so what we're gonna do is we're gonna turn on the LED light tracker. I'm just gonna delete this code. Um, I'll just delete this code. Or I'll just move this to the very bottom. Just ignore this. Ignore what I'm gonna do. I'm just move it to the very bottom so you can't see. Okay, so now we're here. What we're gonna do is we're gonna turn on the Edison uh, object detection beam so we can see obstacles in front. So I just have to get some tissues on my end. So I'll be back. Okay, sorry about that. Okay, so what I want you to do is maybe just follow along my code for the time being. What we're gonna do is we're gonna do add obstacle detection beam. We're gonna turn this on. Okay, so we're gonna do this add dot on, and then I'm just gonna look at my other notes again. We're gonna call this we're gonna call this this thing called Edison register event handler. So yeah, so what it's gonna do is just find this function. If you don't know what this function does, we're gonna look it up here right now. Registered event handler. It has a whole bunch of things that you want to do. So just for context, it has like, okay, for example, obstacle detection beam. This one is like whenever you detect an obstacle, it will call this function. So I'll just let me make it more spread out. So whenever you detect any obstacle or whatever you want to use, whenever you press this button or whenever this thing is triggered, it will call this function. Otherwise, it will run this function forever. So you run this, and then whenever you detect this an obstacle here, it will call this function and return. So let's just do something simple. Let's just call when you detect any obstacle event obstacle ahead. Let's just do when it's like in front. It will call this function called I'll just say avoid obstacle. You should call this function. So let's just make your Edison program while it is true, while it's running. It will just do drive forward. It will drive ed dot. Let's just see what drive does again. Let's make it drive forward. So what direction? Yeah, so we can make it drive ed forward. Make sure there's no two of this. We'll probably make it do ed dot maybe speed. Maybe just do like okay, slow speed. it'll keep maybe driving unlimited. How do I make this drive? Yeah, make it drive forever. Add dot unlimited, and add dot distance unlimited. Will keep it, make it drive forever. But whenever I'll just go back here. Whenever you detect an obstacle being, so not this one. Whenever you register that you detect an obstacle ahead, we'll call this function here. We call it we use this function avoid obstacle. Okay, it will avoid this obstacle, and what we'll do is we'll make the Edison robot add spin. We will make it spin left. We'll do add dot speed full, and it will make it let's just say 180 degrees, because you want to make it spin around in circle and stuff. So let's just see what happens, and I'll explain the code itself. This should be pretty relatively simple to run. I'll just try to run it on my end. Let's try to run this on my end.
Oh, yeah, can you all hear? Yeah, you can still hear me. Perfect. So, it'll probably take a while because of the fact that it is a bigger program and high. So what we're going to do now?
Yes, let's see what happens. So if you look down here, he's going to drive forward and make it. Yeah. That's strange. Yeah, whenever you hit this obstacle, it will drive. So yeah, whenever you see an obstacle, you will avoid it. Yeah, so precisely. Whenever you see an obstacle, it will pretty much work to avoid it. So I want you all to do this on your end. I'll give you all 5 minutes, and then maybe as an extra challenge, try calling a different function. Maybe when, so this is optional stuff. Maybe this is just optional. Maybe when you do, when, what's it called? Maybe, let's just see what else can we use. Register event handler. Um, register event. Where's it called? Maybe when you press the round button. So event keypad round. Maybe what you can do is maybe like let's just say a flash light, and then def flash light. Yep, Aisha, what's up? Can you unmute? Okay, can you unmute? What we can also do is make the left LED light turn on and the right LED light turn on. Add left LED. We can do add dot on, and then we can wait for I think the double quotes should work, but we can use single quotes as well. Um, okay, and we can also maybe wait for a few seconds. We can do ed dot wait time wait. We can do to save time. I'm going to copy and paste this code and just have you demonstrate on your end as well. So what we're going to do is ed dot time seconds. Yeah, I'll turn this here. I'll make the right LED turn off. And I'll copy this again. But then I'll make sure I'll turn the right LED, left LED on and the right LED off. Sorry, and then I will yeah, wait for 2 more seconds and then I'll just turn both lights off. And I'll make the ed beep. So I'll just do the beep first. Ed play maybe play a beep. So yeah, so I'll just be more advanced. I'll maybe change this to 90 degrees. And I'll just do it on my end and I'll have you all try just copying and try demonstrating on your end as well. So we're just going to set this up.
Okay, so now, can anyone still hear me? I see people can still hear me. Awesome. So what will happen now is it's gonna just run this program as usual. And then it will turn around. Any obstacles, it will turn around. And then you'll see if I try to press the circle button. Yeah, so you press the play button. So whenever I play this forever, it will turn the right light on, the left light on. So it will turn on the left light, then the right light, and then you'll play a beat or something like that. I might change this around, not sure exactly what happens, but you pretty much have to basically hit the basic gist. So for example, I play this, whatever the circle button as many times as possible, and then when whenever I like have an obstacle, it'll keep running forever, and then also when I play the light, it'll make a sound as well, sound of flashing light as well. Pretty much. Yeah, so I want you to all just copy and try using this code on my end and try demonstrating this for yourself. And just see the possibilities you have. Yeah, just copy this. I'll give you like until 6:35, so 4 minutes. Just copy it and just try running this code. If anyone has any questions, you can feel free to ask on your end. Okay, Sam, what's up, Sam? Are you good, Sam? Can you hear me? Do you have any questions, Sam? No? Okay, we'll move on. Okay, it's 6:35 now. Who wants to demonstrate?
Okay. We've got nice things on the garage, which we're... Oh, nice.
Does anyone want to demonstrate? Yep, Sam. Okay. What's up, Sam? Yep, Sam, you want
You've got a nice big screen.
So I'm having a bit of a problem. For some reason, the left wheel of
Okay, Alex, what's up?
I want to demonstrate.
Alex?
I want to demonstrate. I want to demonstrate.
No? Okay, so hopefully you get the basic gist of how this thing works. It's a bit fast paced. That's fine. Yeah, just when you have more time, you can look over this at your own time as well, just to understand this concept much further. But long story short, you pretty much create this program to call a particular function whenever a particular event is happening. So for example, when you can detect an obstacle ahead, you'll call this avoid obstacle function. We will make it turn left. And whenever you press the round button here, you'll make it turn the flashlight on within this function here. Otherwise, it will just keep driving. I hope this gives you a better idea how it does. Okay. Alex? Wait, let me... Okay,
Can you try this again, Alex?
Huh?
Oh, I can hear you now. For some reason, there's some issues. Okay. Alex, do you want to try again?
Okay.
My headphones were messed up. Try again. Okay. Yeah, make sure it's away from the computer. Okay, that's pretty awesome. And you drive, and then can you also press play and then try what's it called pressing the circle button?
Pardon?
Can you try pressing the circle button whilst you run your program?
Okay. It beeps.
Yep, it beeps. Nice, awesome. Can you press it again? Yep, awesome. Good job, Alex. Awesome. Okay. Yep. Awesome. Good job, Alex. Okay, Sam. I think I couldn't hear you last time, maybe because of my headphones. Can you try asking the same question again? Okay. Yeah, I think I should be something happens with my headphones, so I couldn't hear anyone properly. So, okay, that's fine. Okay, so what we're gonna do, the last concept we're gonna introduce for this term is class. So this will be a more advanced concept. We're just gonna cover only the surface of it, and objects and stuff. So we have all these functions, we have all these class, but what we're gonna do is, so we have all these functions and we have all these commands that we've used, but now we're going to introduce class, at least the surface level. It's a very advanced concept.
Thank you.
Okay. Aisha, do you have a question? Do you have a question, Aisha? I can't hear you for some reason. No?
Yes, I do.
Okay, what's the question?
After we press program Edison, and before we press program Edison, the light doesn't the light stops. The light doesn't work. But then after the program Edison, the light doesn't also work. Look, like when I
Okay.
click program Edison, it does.
Yep, the two lights.
It doesn't flash like this. It's just
Yeah.
like this.
Yeah.
And after program Edison finishes, it stays like this and doesn't go like this.
Okay. That's interesting. So did you connect? Have you made it work before though? Have you ever made your Edison robot work before, right?
Yeah.
Okay. That's interesting. Okay. So make sure. I think why? Because you have to make sure there's no errors with your code. Like make sure it follows the code exactly like that. No
Yeah.
spaces and stuff. Make sure there's no error, and then you should be able to work. Otherwise, if there's an error, your code will not run. Okay. So this is gonna be the last thing we're gonna cover this term. So this is going to be a more advanced concept. It's called class. So what we're going to cover is, maybe we would call this class called, okay, so what we're going to do is maybe do some musical notes and stuff. So I'm just going to move this all to the bottom. Just ignore this. I'll just move this to the very bottom. But you can do the same, or you can do a new thing. So what we're going to do is create a new class called note, like a musical note or something. Okay. If you don't understand this so far, that's fine. I'll just explain this more in detail later on. So what we're going to do is, I'm just checking my notes. We're going to initialize this class. We're going to call a variable called self, which is referring to this particular note. And then we're going to do a tone, and we're going to do a duration. So a musical tone, like a note. And then whenever, it'll make more sense when we try to utilize it. We'll create, whenever we add some particular variables here, we're going to assign this variable to itself. So this is just going to cover only the surface level. If you don't understand, that's fine, but don't freak out. But this will be very useful if you decide to continue coding. This is only going to cover the surface level. So what we're going to do is, so what we're going to do is maybe just make it like go fast or go slow. Play the note very fast or play very slow. So what we're going to do is speed up. And then we can make the duration equals to half the speed. So half the duration, which means it's going to be much faster. So we're going to use times by 2, which is, divide by 2. This is going to be some basic math you get to do on a computer. And then you're going to do the same thing called speed, just to slow down. Okay, so actually I'll just ask a question here. Okay, so if you want to speed up, you divide it by 2. So you make it shorter. You make the time shorter to speed up. But if you want to slow down, what will you do? You'll be the opposite of this, to slow down. Who wants to have a guess? So what should I make this equals to? What should I do? Question mark 2. What should be in the question mark? Does anyone have an idea? Yep, Aisha, what's up? Yep, Aisha, what's up?
It's still not working.
Okay. I'm not quite sure exactly what's wrong. Maybe make sure you change your batteries, turn on, turn off, and maybe maybe then just reload this from scratch. Reload this again, program again, and yeah, just reload EdPy again and just copy the code again and see if it works.
I loaded it 2 times again, but it didn't work.
Or maybe try closing this page and opening this page again.
Okay.
Okay, let's see if that works. If that doesn't work, then we can talk to the Brilliant Kids admin in the chat and see if we can help out. Okay, so so someone says greater than. Well, that will be helpful if we're comparing it, but we're actually trying to change the value itself. Does anyone have any ideas? Well, dividing by makes it speed up because it's making it shorter. But to what's the opposite of dividing? Who wants to take a guess? What's the opposite of dividing? Multiply. Awesome. So you multiply. Okay. So now what we're going to do is we're going to create the instance of this particular node. So we're going to call it, let's just say we call node, probably call node A equals to, maybe we'll call this class. So we'll create a new class. We'll call it add, because the thing is, like, you will only read these two. Self refers to itself. So what we're going to do is we're going to do a node A. Let's just do the node A. Yeah, let's just do a normal A or something. Maybe 7 octave. That's fine. And then maybe we can do it for like yeah, maybe because this will be in milliseconds or something. So let's just do or equals to 2 seconds. Okay, so you'll make it, yeah, run for duration 2 milliseconds and stuff. And then we can do node, say node. See, we can do C7 here. And then we'll make it play tone. So what we're gonna do is we can do add play tone. You play tone for you play a particular note. We're gonna play this for what's it called? We'll play this particular note. So let's just find this one. So note A dot note. So we'll play itself. And then we can also try doing, we can also play like note A dot duration. So we read this and read that. Okay, so we're gonna play this note. We also play note C, and then we'll try making, we'll try to ask note A to speed up, and then we'll play note A again. And then we'll play note A again, and it would make note C slow down. Let's do note C, make it slow down. And then we'll play that. So I'm just gonna make it more obvious. So maybe ignore this. Maybe let's make it, yeah. So maybe it's gonna make it slightly slower. And you'll make it slightly longer. So yeah, you make note C. So I'll make note A to speed up and note C to slow down. So to make it more equal and stuff. Okay, so let's just see what happens if we try to play this. Okay, so there's some issues, some errors. Oh, we have to make sure we call this program here. My bad. Let's check this. Let's see if there's any more errors. With note. Okay, so what it will do is when you call note, let's just call it tone. That's what I was meant to use. I'm just going to change this to tone and to tone here. Okay, so let's see if that works. Yeah, so you pretty much, this will call the tone here, and this will call the duration here. And then when you make speed up, you'll change the duration. So let me just set this up here.
Just programming right now. If you have a syntax error, that's fine. Just copy my code later on, and then make sure like to program properly, and then let's see how it will go.
If I press play, so it makes a bunch of random sounds and stuff. So it finishes off with this. You finish off with the C note. The C note will be much slower. Oh, sorry. I need to change this to make it C. I'll maybe change the A. I'll just change the A. I'll just change the A to make it maybe make it like 5 seconds, and make it like probably like 2,000 stuff. Let's see if that will help things out. So I'm just going to program this and try running it again. After getting this working,
Wait, let me just set this up again. So this. just programming this right now. Whilst when I get this working and then you are doing the task, I'll explain it some more. Just
Help all of you have a better understanding. So it's playing this tune right now. So yeah, not sure why it's not fully happening, but what's this supposed to do is when you play you'll play the A tone, the tone of A, which is this one here for 5 seconds, and then you play the tone of C for 2 seconds. Then you make it speed up, make the speed much faster, so we'll make it equals to 2,500, and it will make C equals to 4,000 in the end. At least maybe what we can do is just copy and paste the code and just at least observe how A plays, and then C plays much longer. Because we made A speed up, and we made C slow down, which was ultimately the purpose of this task. So yeah, so so Gregory, yeah, precisely, yeah. That's
Yeah,
good
we got 5
explanation.
minutes, so probably
Yep.
just let them about 2 minutes or 3
So
minutes, and then we wrap them up. Yeah.
yeah, sure. Okay, so yeah, I'll just copy this program and try to run it on your end. Whilst you're running on your end, I'll explain this further. So pretty much what this program does, you create an object from the node class. So a class is pretty much like a so how about this? I'll use this analogy of Legos. So imagine a class of node is like the to do like the pictures of how to build a Lego and stuff. So like a blueprint of your Lego. So like that you have to follow in instructions and stuff to build. And this is an object which has an actual built object. So just say a class is like the Lego's blueprint, and an object, which is for this one, is the actual built Lego that you have made already. So so yeah, that's the two different things. So class is something you see on paper, and object is something you see in real life, and you can actually use. So you create an object of node A, which is based on the node blueprint. You set two variables. So this will pretty much makes all the variables and details and blueprints assigned to itself. The tone, you set an A tone, and it will set um, itself to the tone A, and the duration to 5 seconds, ideally 5 seconds. And then C, you set a note you set a note a note of C and a duration of 1 second. So it will be the note of C. C will be assigned to C duration. So 1 second here. This will read from here, and then when you so basically like so imagine this function is like a button in a toy. Pretty much you make note A or toy A, press the button called speed up, and it will change whatever is existing in the blueprint of note. So if you make it speed up, you make it this value divide by half. So like when you press a button in the toy, it makes it do something. So you define what it will do, and it will do something. And then when you make it, and then you eventually play this note again, but at a faster pace, which you pretty much saw at the just now when we played it. And then and when we slow down, you make it times by 2. So the duration, times it by 2. The existing duration is 1,000. So you'll make it 2,000 or milliseconds or 2 seconds and stuff. Hopefully this makes sense. If you don't understand, you can look up this concept called classes. and objects. If you don't understand, this will be a more advanced concept. Please have a look at this at your own time. But just to wrap things up on a more complicated note, this is what we've learned. This is more advanced stuff. If you can understand this now at this age, then you are very smart, very brilliant. So that's pretty advanced stuff. This is the advanced course. So we reached pretty much the end. So I would like to congratulate everyone for reaching the end. Um, who would like to demonstrate one last time um, before we finish off?
They can watch the YouTube
Yeah.
after a couple of days, and they can try to do it again. It's a
Okay.
complicated stuff. So if you understand them, you should be proud of yourself.
Exactly. Yeah. Okay. So who would like to demonstrate? One last person who would like to demonstrate. Anyone? Well, I know we went very fast-paced this lesson, and we learned a lot of advanced stuff, which we mostly rushed through. If you want to revise this concept again, look through the videos and try to make your own projects based on what you've learned using all these tools, and then you'll be able to control your Edison robot and have a good foundation to do fun things with coding in the future. So yeah, that's pretty much it on my end. Anyone has one last questions before we head off? Oh yeah, I know. Aisha, you have some issues. Yeah, I think you just have to talk to the Really Kids admin to see how we can debug this via email, and then we'll try to fix it outside class. Um, anyone else? Any other questions?
Okay, I think we
Nope.
should wrap it up.
Awesome.
I'm
Well,
gonna this is the last class. This is the last lessons. Yes, for this term.
this is the last lesson of the term.
Yes. So we got 8 lessons, and yeah, if you attend all of them, this is the last one.
So you learn very advanced stuff. You should be very proud to
Mm,
reach it to this end. And yeah, this is very useful skill. It will make you very successful in the
yeah.
future or rich if you care about money. So yeah,
So
awesome. Thank you very much. I would
thank
like
you
to say
very
goodbye
much,
to everyone.
Peter.
Unmute.
I'm gonna unmute everyone. Will there be a second term? We will have the second term, but because you bought one Edison robot, you only eligible for 8 classes, which is you finished. If you want to join the next term, you have to buy a new package, because all our package come with lessons. Yeah, and I really hope that you can support us. Right, I'm gonna unmute everyone to say goodbye to Peters. I hope you learned a lot from him in the last 8 lessons. And I see you next time.
Awesome.
Bye.
Okay, see ya.
Bye.
Hope you enjoy this class. See
Bye.
ya. Have a good
Wait,
term.
hi.
See ya.
Bye.